Frymaster's Intuition Fryer introduces innovation on several fronts. Virtually all of its electrical components are DC. Behind the doors of the new fryer are DC-powered blowers. The small filters are easily removed for cleaning. The fans are powered by 12 volts DC, provided by the heat control board, the circuit board that controls the vat and monitors its performance. Also in the upper cabinet, under translucent protective covers, are the 24-volt DC spark modules. Lower in the cabinet are 24-volt DC gas valves, one for each burner. The valves sit on a manifold that includes a pressure sensor, which monitors and reports the incoming gas pressure. The sensor can be seen here in the drawing and in the cabinet. The controllers, which will be covered later, are in front of a set of components, accessible by removing 2 screws. The bezel hinges down, and the heat control board is accessible along with all its connections. The ports on the HCB cover are embossed with their connection name. The HCB case is shown here without cables for clarity. It's shown here with its diagnostic LED positions annotated. A guide to the LCDs is provided in the visual service guide to the fryer. Also in the control box are pressure switches. They are key to the operation of the fryer. They monitor the output of the blowers that feed air into the burners. As the blowers' filters grow dirty, the pressure the blowers generate diminishes. The HCB, which is monitoring the burners via the air pressure, increases the RPM of the blowers. When the fan efficiency falters, the controller calls for the filters to be cleaned. As a safety, the 24 volts for the spark modules is in series with the pressure switch. No pressure, no voltage for spark or the gas valve. The voltage can be measured at the switch when the fryer is calling for heat. The hose connecting the pressure switch to the blower can be seen in this illustration. A switch is shown here, removed from the fryer for clarity. They are a tool for tuning the burner. This factory setting on this dial can be adjusted to produce more or less air. Voltage measured at positions 1 and 3 when the fan is idle should be 9.3 volts DC, plus or minus 0.2 of a volt. Voltage measured at positions 1 and 2 with the fan running should be 24 volts DC plus or minus 1 volt. The pressure hose is always attached to the positive port. The negative port is a vent. The probes in the fry pot are also accessible in the control box. The automatic top-off, automatic intermittent filtration, temp probe are all the same probe and are interchangeable. The oil is back probe is different and works differently than earlier OIBs. It detects by temperature changes and reacts much like the rate of rise approach in electric fryers. If the temperature change is too fast to be within the confines of normal operation, it shuts down the vat. Behind the removable sides, the gas valves are easily reached. So is the power supply for the vat. Each vat has a 24-volt DC power supply that runs the HCB, spark modules, and gas valves. The power supplies are suspended from brackets beside each vat. They rest on pins and are easily lifted out for service. The system control board is found in the box behind the jib. It provides power for operations that are common to the fryer battery, filtration and oil management. The box is accessed after removing the jib and removing its cover. The box contains a number of components, a relay for resetting the fryer and a hood relay on McDonald's fryers, a terminal block to pass line voltage to other components in the fryer, a 24-volt DC power supply, a variable frequency drive which converts single-phase AC line voltage to a 3-phase power for the pump motor. The VFD makes clockwise and counterclockwise movement of the pump motor possible and at a variety of speeds. Only one pump and motor is required to top off the jib for the auto top-off system and move oil for the automatic filtration system. The box also contains the system control board, which monitors the oil quality sensors, the data buses information travels on, and vents that drain the manifolds along with other system operations. Line voltage for the control box power supply, the VFD, and the heat control power supplies passes through the system control box terminal block. The pump and motor assembly is above the SCB. It's mounted on a pivoting bracket that makes access easy. The pump is seen here connected to the top-off and the filtering plumbing. Here it is shown in a plumbing schematic that includes the filter pan and its internal components. Also visible are vents that open to drain the manifolds between filtering and top-off sessions, an inline filter on the intake of the pan, and the position for an optional oil quality sensor on top of the pan. The Intuition Fryer's burner circuit, despite its sophisticated operational systems, is pretty straightforward. A lit burner is shown in this cutaway. The blowers are moving air into the burner. The pressure switches connected to the burner are satisfied and closed. Power is passing from the power supply through the HCB and the pressure switch to the spark module and gas valve, which is open and providing gas as the spark module provides spark. The spark module is also testing for flame using the same flame rectification approach used in all Frymaster closed burner systems. The first order of business in getting an Intuition Fryer installed is getting it off the pallet safely. The box that contains the system control board and variable frequency drive is low, and care must be taken to not hit it on the pallet as the fryer rolls off. To prevent that, there's a low area of the pallet and a guide to ensure the wheels follow a path that keeps the SCB box above the pallet's lowest point. Remove completely the 4 L-shaped brackets that attach the fryer to the pallet. Remove the filter pan from the fryer cabinet. Push the fryer until the rear wheels strike the metal ridge on the pallet. That ensures the SCB box is above the lowest part of the pallet. Ensure the wheels follow the metal ridge as the fryer is moved. Non-SCB box side first off the pallet. Position the fryer near where it's to be installed. Remove the plug in the gas manifold and install a nipple where the fryer is to be connected to gas. Ensure the other gas connection point is plugged. If the fryer is to be hooked to power other than 120 volts, remove the jib. Remove the front of the SCB box. Remove the jumper on the variable frequency drive. Replace the SCB box cover. Ensure the fryer is level. Replacing the fan requires removing the bezel to access its wiring. Remove the screws securing the bezel to the frame. Hook the bezel's tabs into the higher retention points below the control box. Remove the plug from the back of the controller, the HCB. Press the tab with a fingernail or small screwdriver blade. Remove the wire ties attaching the fan wire to the adjacent wires. Push the wire through the opening and below the control box. Press the tabs on both sides of the filter of the failed fan and pull to remove it. Remove the pressure switch hose. The fan assembly, shown here removed, has a notch and a bracket that secure it to the burner. The bracket must be pulled forward and the fan assembly rotated to clear the notch during removal. Loosen the Allen screw below the fan. Do not remove the Allen screw completely. Loosening pulls the split bracket at the rear of the fan forward, clearing the gas line. After loosening, pull the bracket forward. Rotate the fan assembly counterclockwise to align the assembly notch with the gas line. Pull firmly forward. The assembly is held internally with O-rings. To position a new fan, ensure the bracket is forward. Push the assembly onto the burner, ensuring the notch is aligned with the gas line. When the assembly bottoms out against the gas line, rotate clockwise. Tighten the Allen screw to position the bracket around the gas line. Reposition the pressure switch tube. Replace the air filter. Rotate the fan's wire to the control box and plug it into the HCB. Secure the fan wire to the adjacent wiring with wire ties. Replace the bezel. Run the onboard calibration for the new fan. The spark modules mounted under the controllers of the Intuition Fryer have LEDs that can be used for diagnostics. They are shown here with and without a protective cover. The LEDs show electrical activity in the circuit. This one flashes in red and shows latch circuit activity or a failure to sense flame. This one flashes in green and shows 24 volts DC is available at the module. One red flash means the latch controller has closed. The module is ready for a call for heat. 3 flashes means flame was not sensed after an attempt at ignition. The module will try 4 more times, once every 5 seconds. It locks out if it doesn't sense flame. The green LED means 24 volts DC is on the module from the power supply. The LED is lit for the duration of the call for heat. If the power available to the module is less than 18 volts DC, the red LED illuminates solid. If the fryer needs to be reset for any reason, locate the rocker switch inside the left door. Press and hold the switch down for 1 minute. Each gas valve has an on-off switch. Ensure the valve is turned on, the dash position depressed. The fryer's drain should only be cleared by the short 3.4-inch fryer's friend. Longer cleanout rods can damage the valve. Insert the rod into the valve and clear out debris.